We are going to look at arc length and sector area today because I had to leave early and will not be here for the end of class. I'm going to skip around in these notes. I don't want to do everything. I just want you guys to get sort of an introduction on how to do the most simple problems here. So let's look first at area of a circle and circumference of a circle because you have to know those in order to be able to do the area of the sector or the arc length. So if we have the problem like we see here, find the area of the circle below. Area is just pi times the radius squared. So if we are looking for the area of this circle here, we will just do pi times 9 squared. And we'll skip over to Desmos right here and just type that in. So if we have pi times 9 squared, we get 254.469. We round that to 3 decimal places. So 254.569. And because this is in centimeters, this will be centimeters squared for that. So that would be our answer. We just plug into that formula. Circumference is very similar. Circumference is just the length around the outside of the circle. So it is sort of like your perimeter of your circle, but it has a special name. We call it the circumference whenever we're talking about a circle. And our formula here is 2 pi times the radius, or we can use pi times the diameter, depending on which piece of information they give us. So if they ask us, like they have in example 2, to find the circumference of a circle with a diameter of 6 inches, then they gave us diameter, so I would use this second formula. So I would just say the circumference equals pi times 6. Sometimes you'll just see this written as 6 pi. Other times we will actually type it into the calculator, and if we type in 6 pi, we're going to get 18.850 if we round that. And this is just a length, so it's just measured in inches, not square inches, but just inches. Notice if we use 2 pi r, we would get the same thing. We would do 2 pi, and the radius would be 3, and 2 times 3 would give us 6 pi also, which would give us the same decimal right here. So let's talk about the area of a sector. So the area of a sector is the area of like a slice of the circle. So it's like sort of like the area of a piece of pie that we're looking at here. A sector is a section of a circle defined by a central angle and its corresponding arc. So right here we have a central angle, and out here on the edge is our corresponding arc, and we're looking at the area of all of the space contained within those pieces. So our formula for the area of a sector, you'll notice here, includes pi r squared because that's the area of a circle. So really it's just a fraction of the circle. It's just part of the circle. Here, so if I have a sector like in number 3, with a radius of 2 and a central angle of 150, I just plug into this equation and I will get 150 degrees divided by 360 degrees, and I will multiply that by pi times the radius squared. That radius is 2 for this problem. So if I skip over to Desmos here, I would just type in 150 divided by 360 times pi. Let's put that on the outside of the parentheses. Pi times 2. Squared. And I'm getting 5.236 whenever I do that. So the area of that sector would be 5.236 units squared, whatever type of units you have for this problem. Actually, we have yards, so we'd have units. So let's do yards squared. Okay, so that's a general idea. We may go back and talk about this pizza problem later, but for the sake of time, I am going to move on past that. So let's skip ahead to arc length here. So for arc length, you are going to use this formula, area equals theta over 360 degrees, or times 2 pi times the radius. Or you could use area equals theta over 360 times pi times diameter. Notice here, depending on which formula you choose, that these two pieces right here are the circumference of the circle. So when we're talking about an arc length, we're not talking about the entire slice of pie. It's just like looking at the crust of the pie. So we're looking at the length of arc PQ. And this is just a fraction of the circumference. So if I was doing this problem that's given here on number 5, and I'm looking for the arc length PQ, I would use my central angle, which is 135 over 360. So that's the fraction of the circle that we're looking at. And then I would multiply that by 2 pi times the radius, which is 12. So I can skip over to Desmos here. It's not Desmos. And just type that in. So I've got 135 over 360, and then 2 pi times the radius, which is 12, and that is going to give me 28.274. So I'll go over here and get 28.274, and this one does not have units, so that would just be units. It's not squared here because it's just a length, so it's, if you have inches, your answer is just inches. If you have feet, your answer would just be feet. Okay, and so we might talk about this other pizza problem later. So if I look at these two examples that I have right here, for both of these examples, I'm asked for a length of the arc and the area of the sector that is shown. So for this first problem, for my length of arc DC, your arc length is a fraction of your circumference. So you're going to do 100 divided by 360. That's your fraction times the circumference. Circumference is 2 pi times the radius. Our radius is 12 here. So if we type that into Desmos, I'm just going to adjust this, 100 over 2 pi times 12, and I get 20.944. So 20.944, and that would be just in centimeters there. The area of the sector is very similar, but instead of taking that fraction of the circumference, we want to use the fraction of the area. So we would have 100 over 360 times pi times the radius squared there. And so all we have to do is type that into Desmos over here. So I'm going to change this to pi times 12 squared, and I get 125.664. So 125.664, and that would be in square centimeters. Area is always going to be measured in square units. Length is just measured in straight units. Okay. If we look at number 7, we're looking for the length of the blue arc. So that is speaking of like the edge of the arc right here. So the arc that contains the blue area is what they're talking about here. So again, we take our central angle. It is 210 degrees divided by 360. And arc length is a fraction of the circumference, and circumference is 2 pi times the radius. Our radius here is 18. So we just type that into the calculator, and if we do that, we will have 210 divided by 360 times 2 pi times 18. And when we type that in, we're getting 65.973. So 65.973. And this one does not have units, so this would be units here. Okay. For the second part of example 7, it's a little bit of a trick because it doesn't ask us for the length or the area of the blue sector. It asks us for the area of the white sector. So what we're going to have to do here is we first have to find this central angle that goes with the white section. And we already know the other piece is 210. All we have to do here is say 360 minus 210, and that is going to give us 150 degrees. So the measure of this angle here is 150 degrees. And then we will use our area of a sector formula using that 150 degrees. So we'll have 150 divided by 360, and it is area, so we were multiplying this by the area of the circle, so pi times 18 squared, and we are just going to type that into Desmos. Pi times 18 squared, and we are getting 424.115. So 424.115 units squared. So there's a little bit more that we are going to do with this, but this should be enough to help. Okay, so I do have a very short assignment that I want you guys to do on Delta Math. So if you go to Delta Math, your assignment should look like this, 6.4, assignment arc length and sector area. There are 3 sections of this. You do not have to do the last section yet. You are only doing the sector area and the arc length part today, and then we will look at some of this other stuff tomorrow together.